Hello everyone. Today I'm gonna do the project proposal for Internet of Things, which is our posture sense, which is basically a smart posture app. So in today's digital world, most of us spend over tens of hours sitting, and that is often in very unhealthy positions. Whether it is hunching over a laptop, slouching over our desks, staring down at our phones, poor posture has become an epidemic. It's not just about how we look. It leads to our neck and back pain. It leads to muscle fatigue and over time serious muscular disorders that affect our focus and productivity. This mainly affects students who are studying for long hours, smartphone users, gamers, etc. So, uh, what's the problem and what's our motivation for this? Despite the current issue, the current posture correction tools are either too simplistic or too intrusive, mostly relying on time based reminders or camera tracking, which raise privacy concerns, while professional EMG systems are very expensive. We wanted to combine both of them to make a smarter, more affordable solution that gives real time feedback and help users develop better posture habits and safety with safety and effectiveness. So, coming to what are we building? Our system uses a ESP32, which is a microcontroller with motion and strain sensors to monitor posture and detect muscle tension in real time. If strain exceeds a particular set limit, it triggers LEDs or buzzers and sends the data to a mobile app via Bluetooth and cloud. Through this app, users can monitor and view their daily posture scores, track habits, even integrate with data from apps like Google Fit and track their activity effectively, helping them stay mindful and healthy in everyday situations.
So let's now talk about the hardware plan. So the ESP32 runs all the firmware, the Wi-Fi and the math at 3.3 volts, and we power it from a small USB power bank for portable demos. The flex sensor is wired as a voltage divider with the midpoint into ADC1 on GPIO34, giving it a stable analog reads while Wi-Fi is active and letting us track the strap stretch as the local mechanical string. So for the feedback, we drive a buzzer on GPIO25 or a vibration motor through a transistor on GPIO27, and we can add the status LED on GPIO18 for clear visual status. Coming to the algorithm, we fuse gyro and accelerometer at 100 Hz to get clear pitch and roll and map the flex sensor to a normalized stretch percent. Small movements in a free zone are ignored. We then build a simple strain exposure index that is called as SEI that grows with excess angle, stretch, and bend rate and decays during the recovery, which triggers an immediate alert on long forward bends for a cumulative alert when the SEI crosses a safe limit. Coming to the security and the privacy that we have with our design is that each device will use unique credentials and sends the data over MQTT with the TLS. So it's encrypted and authenticated. So we don't collect any personal information, only the device ID with the position metrics. And we can safely tune the thresholds via the device twin within optimal secure OTA updates. Coming to the demo on what our activity would be. So we first calibrate upright the capturing a neutral baseline in 2 to 3 seconds. Then we hold a sustained forward bend. Once it stays beyond a free zone, the device triggers a 10-second alert with a buzzer and a LED. At the same time, a minute summarizes stream to the cloud, so you will see an SEI spike and a bad posture seconds increases on the dashboard. We will wrap with how the cues build better habits and what's next, the auto tuning thresholds and a quieter vibration mode. So that's all about our project. Thank you.